morning, everybody. My name is Ramin Rousbeh, and I'm going to show you basically our management UI of this large-scale storage system that Russ referred to. Also, I have on conference one of my colleagues, Holmes, who is stationed in the Chicago office to demonstrate outages and write and read activities. Alan, can you hear me?
Yes. Good morning, everybody.
Good morning. Hi. All right. So, Cleversafe designed, introduced a new technology, and in order to solve the challenges of making it easier for people to understand how to use the system, try to build a UI that makes everything operator friendly. What you're looking at is a web UI, so it's our manager user interface through the dsNet manager. So I can, as long as I can access the IP address of the manager from anywhere, I can browse to it. And so when you log in, you immediately are presented with a dashboard view of the entire dsNet. And the dsNet stands for Dispersed Storage Network. So what we're looking at is basically all of the events generated, a summary of the components in this dsNet, the total dsNet capacity, and then you notice different tabs at the top that are, provide different functionalities into managing this environment. On the left-hand side, you see a tree view of what is included in this dsNet. So, for example, this is the evaluation dsNet we provide to our customers or we use for demos. As you can see, we have 74 vaults. A vault is a term we use for a logical container. Other people call it buckets. We call it vaults. So as you can see, we have 74 of them in this manager. There's really not a limit. Depending on the model appliances you choose, you could scale that into the sizes that you need. And then, so these are different customers and or demos. And in terms of next, you have storage pools. Storage pools include slice store. These are storage nodes, and you can create pools for different purposes. Perhaps you need a storage pool that's in a single site, or you have a storage pool that's spread across 3 or more sites. In the case of the eval dsNet, we have a storage pool that's across 8 sites, as Russ presented the map of the United States with the different locations. So we have, in this environment, we have 3 different pools, one dedicated for media entertainment. So if I open that up, you can see the storage nodes that are part of that storage pool. Next, we present you the sites. So these are, through the UI, they're logical sites that represent physical sites. So when we create these logical sites through the UI, we assign which storage nodes belong to which site. And as you can see, there's different colors associated to the nodes and to the sites. And these are indications of events happening in the system. For example, if I lose an entire site, my site will go red. Or if I lose individual components within the site, depending on how many failures I have, it may be yellow or it may be red. Next, we have basically the devices. There's
one quick question.
Sure.
Is that the color changes? Is that a user selectable metric, or is that built into the system? Can you say I want so many failures before it turns red? Or
sure, you can do that. So you can assign how many nodes in a pool or how many nodes in a container you could lose before it goes to yellow. So we have the default read and write thresholds, as Ross mentioned. If the system goes below those thresholds, it will automatically go to red. However, you can set an alert such that it's higher than a threshold. You may still have read and write threshold of the nodes available, but maybe you lost 2 nodes, and maybe you don't want that to be yellow yet because you have additional nodes you could lose in the system. So you get to play with that. So there's a feature available for that.
Thank you.
Sure. And then further, you can also dictate how many drives you can lose within a storage node. Maybe you know, because we can lose as many drives within a single node. As long as there is a single data drive left in the system, that node is available for read and write. Definitely write access, depending on where those slices were for read. On that particular node, they may not be available for read. So you can assign that, adjust that, when do you want that node to be yellow after how many disk losses. So then you could get an idea of the 3 different components. So there's a single manager with any dsNet, and then there could be a number of accessor appliances as well as slice store appliances. So in this dsNet, we have 4 accessors and 28 slice stores. We also have other dsNets for customers that are in production, as well as Cleversafe's own usage across different configuration of these sites. So if I, for example, so this was the dashboard view. Now if I want to go into a monitoring mode, I basically I'm presented with a slice store device summary. There's the breakdown is by the sites, the storage nodes located at those sites, and how much capacity is used in those nodes. So this, I get a sense of where I'm going to run out of space, where I have to add new storage nodes. I can further use this by, for example, if I'm writing to, let's imagine that I have a container that spans across 8 of these storage nodes in Chicago. And for example, this happens to be one of those containers. As you can see, each node here has used 1% of that container. The node could have unlimited capacity, and the container could be set to use all of that, so the container being the vault. The vault can be set to use all of that capacity, or you can assign quotas, and I will demonstrate that later. But this gives me an idea if a storage node falls behind. You know, for example, it turns red. Maybe I lost it completely. Maybe it's been down for a while, but I'm still writing to this environment. Certain nodes will fall behind, and I can see that from here. I can understand which nodes will be doing rebuilding work, and how far behind are they, and when will they catch up. There's other charts that help you figuring this information out. So now if I click on a vault, for example, let's select this first vault. I can see all of the accessor devices that are deployed on this container. So through any of these accessors, I can read and write to this container. And then the storage pool that I'm using for this container, so for this vault. As you can see, we're using the media entertainment storage pool, and those are the storage nodes associated to it. And each one is at a site. So we have 2 in Dallas. We're using 2 different IP and data center providers. 2 in Chicago, so those are 2 different data centers, a New Jersey site, a Denver site, Seattle and San Francisco. And then I can see the storage capacity for this particular vault. How much raw space is available, how much usable. And down here, the events that are associated to that vault. As you can see, different vaults are using different amounts of space throughout the system. Now, if I go further down, I get to see raw space usage. So depending on the time of the reads and writes, I will see data on the raw space and or the data that's passing through the accessors. You don't see anything right now because there's no reads and writes happening on this particular vault. But when I create a vault, we will demonstrate reads and writes, and you will be able to see data on those graphs. And then we have rebuilding. So rebuilding, as Russ touched on it, every storage node has a rebuild capability in the background. They're constantly scanning to see if they're missing slices and or if there's any corrupt slices. Once they identify the corrupt or missing slices, rebuilding will occur. And you could see which nodes in the vault are doing the rebuilding. And basically, you get a printout out of that. So the system scales. The more nodes I add to the storage pool, or if I expand my vault across many storage pools, the more rebuilding power I have. And this doesn't affect the performance of the user or client application because it's happening at the storage layer. The accessor layer is where the reads and writes are happening. And so this is completely separated with that. And both can scale, and you can basically use your total system throughput. Before I get into the configuration section, I want to walk through the other areas of the system. So, for example, security, I can integrate this with Active Directory or use PKI. These are all external authentication mechanisms. Or use the dsNet manager's own local authentication, creating local user accounts. Different accounts can have different roles. As you can see, roles are defined over here. Depending on the role you're assigned to, perhaps you're just a vault user, and you can read and write to a vault, but you don't have access to the dsNet manager. Or you're an operator, you can monitor the system, or a security officer, which is responsible for creating accounts, assigning security, or a super admin who has access to everything in the system. So we support RBAC, and you can assign different roles to different individuals in the organization. Let's see. So we also have auditing. Any activity that happens on the dsNet manager, it's captured. Who is creating what user account, providing access to what container, what was the last changes made by myself or another member of my organization.
Are there APIs that can tie into that if you have other systems that you use for auditing and change management, things like that?
So we have, through this dsNet manager, we also provide an API. And so if you integrate with your third-party solutions to this manager API, you're able to pull information that the manager can directly through the API so that you can use your own third-party applications. So here I can basically do searching for different types of audit activity in the system. As you can see, I logged in just now today, and it's basically showing, earlier I was doing some work, and it has captured that. In maintenance tab, this is where we basically upgrade the storage system as well as get a printout of all the disks within the system. So a system that scales to 75 petabytes or more, for example, in the Shutterfly case, you're talking about thousands of disks. And instead of going through all of the event messages to figure out how many disk failures I have and whatnot, I can basically come here and select View. I get a chart of all the disks in the system. I can filter them depending on the conditions that are present. I have different options. If I have disks that have failed, I will have an option for failed disks. At the moment, I have all the disks that are good and a few that are unusable. So if I select unusable, those disks will appear. So I have, for example, on this storage node located in Denver, on this particular model, there's something wrong with this disk. So I can go further in that storage node and look at the events associated to that disk failure and figure out what's going on. And I can also export this data out to, if I need to present it in a management slide deck to the other teams in the company. In terms of upgrading this system, what we have is a rolling-based upgrade. So in a system that has thousands of components, obviously it takes time to upgrade such a system. And our model is, as long as you build the system correctly with the right IDA parameters spread across geographical sites to provide site availability, you can provide 24/7 read and write access to the storage containers for reads and writes. Because anything that you have to do in the system, as long as you can guarantee a threshold number of nodes available anytime, you can provide access to your users or to your applications. In the case of an upgrade, when a new upgrade file is, when Cleversafe provides a new upgrade package, this includes features, kernel updates, any operating system updates, security enhancements, improvements, performance, or whatnot. But basically, you drop the package on the manager appliance in the step 1. Step 2, you upgrade the manager appliance. Once you do that, it recognizes that the rest of the components in the system are on an older release. Obviously, this does not stop read and write access. Our system is designed such that you can have many versions on different components, and at the same time, this environment is ready for use. So it is further broken down into storage pools. Obviously, these are the nodes that affect the vaults that are deployed in this storage pool. So we have grouped them here such that when an operator decides to do an upgrade, they have an understanding of what they're doing, and so they don't by accident make the system unavailable. There is, you asked about the alert threshold and or whether the operator can assign that manually. So the other benefit of that alert threshold is to control how many components you could upgrade at the same time. Okay? For example, if I have an 8-byte system and I set my threshold to, for example, 5, I can upgrade 2 nodes in this system at the same time. A much larger, a wider system, I have more room to upgrade at the same time. So I can come into this storage pool and upgrade a node at a time manually if I wanted to, and just wait a couple of days to see if I'm not comfortable with upgrading the entire storage pool. Or I can kick off the upgrade entire storage pool, and that will, based on my alert setting, take down a few nodes, 1, 2, or 3, depending on these settings, and upgrade those nodes at the same time. And then on the right-hand side, so as you can see, this is the throttle. The throttle right now is set to 1 because these are 5 of 8. So it's 8 storage nodes wide with a read threshold of 5. That means in this storage pool, only 1 node would be upgrading at the same time. Now, I can kick this off and, for example, leave the office and come back the next day. If a node failed, and since I can only upgrade 1 node at a time, now I have gone below my alert threshold. The system stops upgrading until it gets further instructions from the operator. So this will halt. The operator will come back the next day to see what happened with that node, address the problems of that node, and then it will start upgrading the rest of the components again. As I said, this is adjustable based on your policies. And then, so they're all broken down into the different storage pools that are available in the system. Anybody has any questions about the upgrading process before I move on?
Can we roll back?
No, so we don't support a rollback option. In our experiences, we have never come across a need for that. So it's just moving forward. Because we can tolerate. So you have the option to upgrade maybe 3 of these to 283. Wait a couple of weeks. If you're not happy with that, the other nodes are still available, and then we can, if there's any issues, we can address those issues.
So there's generally no problem concurrently running different versions within the same pool, right?
Absolutely not. So moving on to administration, here we provide a bunch of different options. So for example, the manager backup and restore. There's a couple of ways you can do that. You can create local backups. You can back up the configuration and the stats to an FTP server. A new feature coming out soon is that we're creating the ability for the manager to back up its configuration and stats to a vault that's spread across the storage nodes so that we can apply the same reliability to that information or data as we do to a regular data. So there's some choices with that. And then so the SMTP configuration, if you want email alerting, so you would configure your mail server with that. alert rule configurations. I may want, maybe I'm a large organization and I have different teams responsible for different components of this dsNet. Perhaps I want all the disk-related issues to go to a storage admin and all the network issues to go to the network admin. So I can do all of that. Active Directory and certificate authority configurations. These are if you want to use the external, either an external CA or the AD account for authentication. TLS, we allow you to encrypt tunnels between application servers to accessors, from accessors to the storage nodes, such that data in motion is encrypted as well as data at rest. Drive health configuration, this is the area where you can dictate how many drives you can lose in a single node before that node turning yellow or becoming unavailable for further reads and writes. And license key basically enables different features in the system. Now, I'm going to show you how easy it is for an operator to create a vault. Basically, I click Configure, and then next I'm presented with a bunch of options under Summary: create vaults, create storage pools, create sites, or create cabinets. The cabinet gives me, if I'm interested and I want a logical view of the components and which use they are in my cabinet, as well as other components inside that cabinet, I can create such a thing, and the Manager UI will present that information to anyone who wants to monitor it. Therefore, it has the capability of monitoring your other components in your network. For example, the switches associated to this dsNet. Now, I also, on the right-hand side, I have the option to do the same thing over here: create vault, create storage pools. So I'm going to create vault. OK, so when I create vault, I'm presented with 3 storage pools. One is dedicated for media entertainment and the dsNet evaluation environment. I also have a pool that's local. All the storage nodes are located in one data center, and another one that's across 4 data centers. And you could see the breakout here. So sites 8, this one is 1, this one is 4. And the width basically tells me how many nodes are in this pool, therefore what kind of an IDA IDA policy I can assign to it. So I'm going to select media entertainment and press continue. I will call this A Tech Field Day. And now it comes to configuring the IDA. In larger systems, in pools that have way more storage nodes, I can create an IDA width, which is how many nodes will my container span across, as large as that pool allows me to. In this one, we have 8, so I'm limited to 8. And then the next is, how many of those nodes need to be available for me to successfully read back the objects? So I can assign 5, 6, or 7. But for tolerating more failure, I will assign 5. And then there's a write threshold, which by default is 1 more than the read threshold, because you always want to have a safety room. You don't want to be writing at the same amount of nodes that you're reading from, because in case of being at the threshold, there is potential chance of losing your last write. So it's set by default to 1, and it could be higher than that, depending on what I want to assign. And here's the alert threshold, which I was talking about earlier. So it's set to 7, such that if I lose a node and I have 7 nodes left in the system, I'm still above my read and write threshold, but the vault will turn yellow and alarms will start going off. Secure slice is basically the feature where we encrypt the data before it's sliced up, such that an individual slice, if someone comes across a disk, a node, or a site, as long as they don't have access to a threshold number of nodes, there's nothing they can do with that data. There's nothing there to make sense out of it. I have the option to set quotas or not. A soft quota gives me a warning when I reach that limit. A hard quota will stop that vault from exceeding further. So we'll put 5 terabytes here, 1 terabyte here, or 3 terabytes here. Not that we're going to be writing that much data today, but so now I have created my logical vault. In the background, this vault is being spanned across 8 storage nodes. That was all to it. If I want to get an idea of why I'm selecting the different parameters that I'm selecting, we also provide a dsNet calculator, which helps the operator to understand, given the parameters they use for the IDA, what does that translate into an expansion factor, and what does that translate into a number of nines of data availability, as well as number of nines of data read and write availability. And for me to quickly show you that, if I go here, help index. So this way they can communicate back to their management team saying, if I design such a system, I'm delivering this many nines in my policy, okay, in terms of reliability and availability. And here's the expansion factor. And if I use this particular model appliances that have perhaps 12, depending on the model, 48 or 60 drives, and what the drive size is, it tells me how many storage nodes I have to purchase. So this is really a helpful tool that helps the operator to plan ahead such that they can place in whatever order of storage nodes they need to satisfy the policy they like to deliver.
Infinity years, I like that.
Yes, so there are policies that provide data reliability greater than 15 nines. And we're talking about mean time to data loss. I can't even count that. It was trillions of years. You will never reach it, so you will never lose that data. So now we created the vault, and now I have to deploy this vault on Accessor appliances. So deployment. I can add this container or deploy it on as many accessors as I want, and depending on the throughput that I need, or the access point locations I want to provide to this container, I will make my decision based on those. So right now, I'm deploying it on 2 Accessor appliances. I also want to demonstrate the stateless part of our feature with the Accessor. My colleague will be doing, when I'm finished with this, writes through one Accessor, and I will show you how I can read that object back through a different Accessor. So as you can see, this is constantly showing me the different configurations that I have selected for this vault as I move down. I have the option to provide authorized IP addresses. So for this container, which server IP is allowed to communicate to. For the purpose of this, we won't do that. Changing user rights, who can access this, basically this vault. Where is my vault? So this is the vault that I created. Now I'm going to say who can access it. For the purposes of the demo, I'm enabling anonymous access. So anonymous, without a user ID and password, I can read and write to it. When customers, because obviously authentication adds another layer to the system, depending on what service you're providing, whether this is a public internet, a public cloud, or a private cloud. For example, in the case of Shutterfly, this is behind a firewall. They control connection access to the different environments. They may decide to use anonymous because it helps with performance instead of authenticating every time for read and write operations.
I mean, the list of users you showed in this previous slide, that's fed by the Active Directory connection?
Many. So there's some of it that I have created locally on the manager. So they are defined here. If we go back to authorized users, change. Oh, it's taking time. OK. So you see this one, it says AD user, because this is an AD user account. This one is a local account by default, an admin account that comes. The ones that have an ad domain name, there are AD. The ones that don't are local accounts. But obviously, you can figure out which ones are which.
If anybody's curious,
15 nines is 31.5 nanoseconds in 10 years, according to Google Calculator.
So basically no data.
Gee, I could live with a whole microsecond ago.
That's completely unreasonable, Howard. So has anybody ever lost data with power or with these devices at all?
Not, not knock on wood, not till this day.
Never data loss, never integrity issue,
You create so much reliability and availability with these IDAs. It's almost impossible unless, you know, if you, for example, deploy all the nodes in a single site and that site is wiped away from the planet, then you lose your data. Okay. If you don't, if you're deployed across multi-sites and you lose more sites than you should allow, for example, you know, if you lose a couple of sites and you just don't plan what to do now, yes, it's possible. But on its own, if it's, you know, stays above its threshold, we have never lost data. So now I've switched over to Alan Holmes, who is located at our Chicago office. We're showing his view. So Alan, I have created a vault called A Tech Field Day. And go ahead, hopefully everyone can hear you.
Okay. So I have a script here of progress _ HTTP upload. It's a bash script that simply uses curl, which is a command line HTTP client, to put a file up onto the dsNet. So I'm going to go ahead and execute that now, and I'm writing into the ATEC Field Day vault that Ramin just created. And you'll see now the progress bar going across. I'm going to stop it for a second. You can see the size of the object I'm writing here. I'm just continually writing the same file. Displays the transfer rate and the time for each transaction. The file I'm writing is actually this image, which is the 1.5 meg that I'm putting up there. So I'll go ahead and start that up again, and you can see that I'm writing the file successfully. Ramin, I don't know if you want to show any I/O at this point, or would you like to go ahead and break down one?
Can you hold on one second so I can show the I/O? And also notice how every write is returning back an object ID. So he's writing the same file over and over, and every object ID is different associated to that specific write. So now he wrote some data, and I'm going to switch back to the vault that I created. So A Tech Field Day, you can see I've already written, based on the commands that were executed, 13.74 megabytes. I click on that. I'm in configure. So if I go to monitor, also we're using the hotel's Wi-Fi, so it's kind of slow. All right. So there you go. Raw space used so far. And you know, the manager is basically polling the appliances, all of the appliances in the system. And as it gets to that particular appliance that is associated to the activity that I'm doing, it updates the information for that on this UI. So if I hit refresh, we may see some more inputs. Okay, so you can see that scanning has already started. I'm eventually going to see some data inside the accessors too, but basically it shows the throughput from Alan's machine to the accessor, from the accessor to the storage nodes. So now Alan is going to demonstrate a continuous write to the system and start taking nodes down in the system, and we're going to demonstrate what it means to be at write threshold, what it means to go lower than that. Obviously, if you go lower than the write threshold, writes will stop. So I'm switching back to Alan's screen. As you can see, writes are continuing. Go ahead, Alan.
Okay, in this window, I'm connected to a switch. I'm going to shut down that switch port to simulate a device failure. And in a moment, you will see that device health indication turn red on Ramin's screen, and I'm going to go ahead and shut down a second device in another one of the POPs here.
Okay.
So
As you
point
do
we'll
that,
have two devices down.
all right, I'm going to switch over. So as Alan is taking the nodes down, he took one from Dallas, he's taking another one from Chicago. We should see those nodes turn red. Once they turn red, they are no longer available for read or write operations. So as you can see, Dallas is already turned red. I'm going to switch back to Alan's to show you that the writes are still continuing. Going back to Manager UI.
I also shut down one of the devices in Chicago while you were showing that Ramin, so you should see the node in Chicago come down on the manager here in a second too.
So I'm refreshing that right now.
You can see here in this window the writes are still continuing on, and we're still getting object IDs back from the transactions.
Right. So you could see Chicago DC1 lost its node. So we see that, Alan. Switching back to your screen.
Yeah, so the writes still continue with two nodes down then. And you want me to go ahead and bring down a third one then? So we're going to see the writes fail at that point, Ramin?
Yes.
Okay, I shut down another switch port. We are now have three devices down, and you can see that the writes have stalled on my screen here. In a second, you'll start seeing some errors come back from that, and Ramin can show you that we have three nodes down.
Notice with the two nodes down, the vault automatically turned yellow, and now we should see the third one. Now the system is still available for reads, so the vault will not actually be read until you lose the read threshold as well.
And now you can see on my screen that we have started to get 500 errors of storage I/O error writing to object vault. So we are not able to successfully write to that vault anymore with three nodes down.
Okay, so we have lost, the manager is telling us that we have lost three nodes in the system. Writes are no longer successful. However, reads are possible. So now, let me see if I can show you some more charts. Okay, so this shows the raw space used. And now, switching back to, let me see. We're going to demonstrate the Accessor Resiliency. So now, if Alan, if you can give me an object ID. So you were using Accessor 77 to write that data. I'm going to use IP ending 77. So IP ending 76 for me to read that data back. So if you can text me the object ID to one of the successful writes.
Working on that now.
Thank you.
There's the entire URL you need, and there's just the object ID by itself, whichever one you want.
Okay, so that's the accessor. So this is the IP address of the accessor that Alan was using. A read is an HTTP GET. So all I need is HTTP, the IP address of the Accessor appliance, because I'm using one of the APIs were offered by the Accessor, and then the vault name and the object ID. So if I click on this link, I will see I'm reading back the object through the Accessor that Alan uploaded to.
Actually, no, Ramin, that URL is .76. That's the one that you're reading from.
Oh, sorry, you were using 77? Okay, my bad.
Yes.
So You made the change. Okay, I was planning on changing the IP address myself, so 76 is, it was not able to, it timed out. Did you open it up on the firewall?
I never changed that. Okay, let me double check that, Ramin.
Okay.
Can you try 77?
Let me check. That one is not working either. Maybe they're both behind the firewall.
I'm double checking that right now again, but I didn't close them from the last time.
While he's doing that, I'm going to check the IP address. Oops. So I have two accessors, 216, 149, 186, 76, and 77. If you wait for a few minutes, technical difficulty.
Is there any questions while you're waiting to get this resolved?
Yeah, I have one. So the nodes Alan shut down, that was a clean shutdown?
And basically, you can consider them as a network outage, because what he did was he logged into a switch that the nodes were connected to, and he disabled the port.
Okay.
However, you could demonstrate unclean outage too. I can go yank the power cable.
No, that's okay.
And when the node comes back, it only checks the integrity of data, or need to rebuild all the equations? Or
When the node comes back on again, the manager is able to gather the SNMP traffic that's being generated and figure out what's going on. The node itself is able to scan, figure out if it was behind in terms of writes from other nodes. So if writes were continuing, for example, when he took the first node down, we were still writing to the system. Therefore, that node is now behind as compared to the other nodes. And once it establishes its network connectivity, the rebuilder process or the scanning process identifies what's missing. Rebuilder process will rebuild that missing data.
Okay.
But rebuilding is a function of the slice store node, and it just reports back to the manager of what it's doing. Should I try again, Alan?
Yeah, yeah.
So how does it know what it's missing? Does the accessor keep a record of what has been written and what should have been written to which node?
No, so the accessor is stateless. It's not responsible for anything. The slice stores basically go to the storage node sisters in the storage pool, and they go, publish me your list of slices. And they get it from a couple of the nodes, and they compare it against themselves. And this happens really fast. And once they identify, okay, everybody else has this slice, and I don't. So it marks that I got to repair this slice, or I got to rebuild this missing slice.
But that's based on the policy of the vault, right? Like, so it knows that I don't have this slice, and this vault policy says that I need to have a slice, right? Or
no. So what happens is when you configure this environment, there's a manager registry. This registry is cached on the accessors, on the slice stores, in terms of for the accessor, for it to know that what container is deployed on what storage pool. So if someone is sending an authentication, if someone is sending me with this credentials to this vault, I can direct the traffic, the reads and writes requests to that vault. On the slice store goes, okay, these are the other storage nodes that are part of this vault that I'm also a part of, okay? And it tells this storage node. So the IDA that sits in the accessor that deals with the data that the user is sending or trying to retrieve, there's also IDA that sits behind in the background on every storage node. So when the storage node tells storage node 2, give me your list of slices, that sends it through the TCP/IP communication to that storage node. And then, OK, I'm missing this slice. OK, could you all send me a threshold number of slices that I need for this segment of data for me to rebuild it? And then it does that. And once it figures out the equation that it needs to make, it discards those slices. It's not like they go back or anything. And then it moves on. So basically what happened earlier is this is a secure environment, OK? And there was a firewall blocking my access from this public internet to that. So Alan opened it up, and I'm able to read this image back through that accessor IP. Now I will demonstrate the same, or actually let me just change the IP address here, 76. So accessor is stateless. If I have the object ID, the accessor knows that I'm telling it, give me this object ID from this vault. The accessor, based on the registry information that's cached onto it, knows the storage nodes that are part of that vault and sends the request to the storage node. The storage nodes send the slices that make up this object back to the accessor. Accessor reassembles them, sends it back to the user. Any questions?
Yeah, just to clarify, this now works as a demo because of this file being a picture, right? If that was a binary file, it looked like something else in the browser.
Right.
Of course.
It would not. I mean, if your web interface had the the code that could translate that type of data to something, then it would present it in the right fashion. But the browsers are able to present images and videos, and anything else, well, then you have to make sure that that browser can support it. So by default, most browsers support most common image file types and video file types. Any other questions? That brings this portion of the demo to an end. Thank you, Alan, for your help.